Hello everyone, it is my great honor to introduce our recent work, FlowMur, a stealthy and practical audio backdoor attack with limited knowledge. This work was done in collaboration with Xidan University in China and Purdue University in the US. Speech recognition systems, which aim to convert speech into text, and improve smoothness of interaction, improve accessibility and productivity. These systems are ubiquitous in our daily life and even used in safety-critical applications such as transcription services, voice assistants, smartphones, and voice capture. Therefore, it is important to study the security of speech recognition systems. Backdoor attacks, which was proposed in 2017, is a new type of attack against DNN models. It aims to insert one or more hidden backdoors into a DNN. Thus, the infected model performs well on benign samples, but misclassifies samples with triggers, also known as poisonous samples, as a target class. Although backdoor attacks have gained a lot of attention in the image domain, it is not well studied in the audio domain. We reviewed existing audio backdoor attacks from 5 aspects and found their limitations. Firstly, we found that most of existing backdoor attacks utilize redundant triggers such as brothers and ultrasound. They are simple and easy to deploy, but less effective than those with optimized triggers. Secondly, most attacks assume that the adversary have sufficient knowledge about a target model or victim dataset. However, this assumption increases the difficulty of their deployment. Thirdly, there is a lack of in-depth investigation on the stealthiness of audio backdoor attacks. Few studies with little consistency and trigger inaudibility. Moreover, trigger imperceptibility reflecting the stealthiness from human perception has not yet been investigated by previous research. Fourthly, while designers of attacks have tried to deploy audio backdoor attacks in practical, these deployments do not meet dynamics well. A dynamic backdoor attack can be launched regardless of the attachment position of a trigger to a benign sample, which cannot be achieved by a static backdoor attack. Lastly, the defense resistance of previous work has not been well studied. To overcome these limitations, we propose a new audio backdoor attack named FlowMur. Before introducing it, we show its threat model first. The main adversary goal of FlowMur is achieving excellent attack performance, that is, attack effectiveness. In addition to this, the adversary expects FlowMur to achieve some good properties, such as trigger universality, trigger inaudibility, dynamicity, and robustness. We assume the adversary can excise and modify samples from target class and collect auxiliary samples and models. To the best of our knowledge, this is the most strict restriction for adversary knowledge and capability in the current literature. Okay, let's explore FlowMur. FlowMur consists of 4 stages: warm-up preparation, trigger generation, data poisoning, and backdoor injection. Warm-up preparation stage aims to overcome the challenge of insufficient adversary knowledge, thus facilitating the subsequent stages. Specifically, the adversary collects an auxiliary dataset and an auxiliary model to train and obtain a surrogate model. After that, trigger generation stage aims to generate a trigger with some sound properties, such as the trigger should be effective for any sample, effective for any attachment position, resistance to ambient noise. It also should have small amplitude value, thus facilitating FlowMur stealthiness. To achieve these properties, we formulate trigger generation as an optimization problem and incorporated these properties or requirements into the optimization equation. The solution of this optimization equation uses some trigger. Okay, after obtaining a sound trigger, the adversary poisons the training dataset and constructs a poisonous dataset. Firstly, the adversary can only poison the target class samples according to the threat model. Secondly, the trigger attachment position of each sample should be randomly selected. And lastly, Human hearing perception of a trigger varies across host samples. Thus, to further enhance the triggering audibility, we designed an adaptive data processing method according to signal-to-noise rate. The last stage of FlowMur is backdoor injection without any involvement of adversary. Any user who employs the poisonous dataset to train a DNN initially completes the backdoor injection. Okay, we evaluated FlowMur from 4 aspects: effectiveness, practicality, stealthiness, and defense resistance. Firstly, I briefly introduce experimental setup. The experiments are conducted on 2 datasets, speech command dataset and foldable keyword dataset. 2 evaluation metrics are used. The first one is benign accuracy, and the second one is attack success rate. We selected MBA as a baseline method and further extended it to meet dynamicity, named MBAD. As for effectiveness, from Table 5, we can notice that FlowMur can achieve attack success rates of over 98 on both datasets without compromising their benign accuracy, which is much better than baselines. In addition, we also explored the impact of several parameters on attack performance. You can find it in our paper. As for practicality, we tested the performance of FlowMur for attacking recorded audio and live human speech. The results show that FlowMur is still effective in the real-world scenario. We designed a human study named Clean Also Species to evaluate the trigger imperceptibility of FlowMur. We conducted 2 tests. The first one is comparing the stealthiness of FlowMur with different SNR. The second one is comparing the stealthiness of different attack methods. The results show that the stealthiness of FlowMur significantly surpasses that of the baselines. Lastly, we tested the defense resistance of FlowMur and baselines against 4 different defense methods, including filters, sampling, strip, and matrix. The results show that defending against FlowMur is not easy. Let's have a conclusion. In this work, we proposed the FlowMur. It requires a knowledge-limited adversary, demonstrates excellent attack performance on 4 models across 2 datasets. It can achieve strong stealthiness and is practical in the real world. At the same time, it can bypass both traditional and advanced defenses. In the future, we plan to explore FlowMur's benefits and deploy FlowMur in audio model ownership validation and dataset ownership validation. That's all. Thank you.